Well, welcome to this online revision session for AQA D1, which will be looking at the June 2011 question 7 on linear programming. Well, you can see in this particular question we have a builder who requires screws, nails and plugs, and in the local store their packs contain a mixture of 3 items. So a DIY pack has 200 nails, 200 screws and 100 plugs. A trade pack has 1000 nails, 1500 screws and 2500 plugs. We're told the cost of each type of pack, and we're also told the builder needs at least 5000 nails, 6000 screws and 4000 plugs, and the builder will buy X DIY packs and Y trade packs and wishes to keep his total cost to a minimum. So the first part, we've got to formulate the builder's situation as a linear programming problem. Okay, and you can see there are 4 marks for this, so chances are there are 4 statements that we will need to make. So what do we know? Well, we know that the builder needs at least 5000 nails. So if he buys X packs of DIY containing 200 nails and Y packs of the trade pack containing 1000 nails, then we can say that 200X plus 1000Y, and that will calculate the number of nails that we will have bought, and that will be greater than or equal to 5000. So if we then divide through by 100, or in fact we divide through by 200, that will tell us that X plus 5Y must be greater than or equal to 25. So there's our first inequality. Similarly for the 6000 screws, the X packs of DIY have got 200 in them, so that's 200X. The Y packs of the trade pack have got 1500 in them, so that's 1500Y. And that has to be at least 6000. So once again, we can look to see what we can divide through by. We'll divide through by 100 this time, and that will give us 2X plus 15Y. It's got to be greater than or equal to 60. Finally, we've got the inequality for the 4000 plugs, so 100 are in the DIY pack, so that's 100X plus 2500 this time, lots of Y, and that must be greater than or equal to 4000. So this time we can divide through by 100, and that will give us X plus 25Y is greater than or equal to 40. So those are our 3 inequalities, which will give us our 3 marks, because each one of those will give us a mark. But that doesn't completely formulate the problem yet, because the other thing we need is the fact that he's trying to minimize the total cost. So we need a formula for the cost. So the cost will be, well, it's £2.50 a pack, so that will tell us that 2.5, £2.50 times X will be the cost of those X packs, and then each of the trade packs is 15, so that's 15 times Y, and that will give you your cost. So that's the thing we're trying to minimise, and that gives us our fourth mark. Okay, on to part B. It says we've got a grid on which to draw a suitable graph showing the feasible region and the direction of an objective line. Okay, so here's one that I've drawn earlier. Firstly, the inequality we were trying to draw was x plus 5y is greater than or equal to 25. So remember, we put it equal to draw the line. So if x is 0, y is 5, so that's the red line. And if y is 0, x is 25. So the red line is the one we've drawn in. We want it to be greater than or equal to 25, so the point 0, 0, when substituted in here, obviously gives you an answer less than 25. So below the line is less than, so that's the piece we don't want, and we're shading out the piece that we do not want. So everything below that red line is not appropriate. Similarly, the second inequality was 2x plus 15y being greater than or equal to 60. So if x is 0, y is 4. If y is 0, x is 30. So that's the blue line that we've drawn in. So once again, 0, 0 gives you an answer which is less than or equal to 60, so below the line is what we do not want. So once again we shade out below that line. Finally, the third inequality was x plus 25y, and that has to be greater than or equal to 40. So once again, if x is 40, y is 0, and if x is 0, y is 40 over 25, which gives you an answer of 1.6. So this is the pink coloured line. So once again, 0, 0 gives you a value less than 40. So below that line is what is not required, so we shade it out. So what we do require is not shaded, so our feasible region is this largest section of the graph here. This is the feasible region. And you can see it's got a vertex at 0, 5, it's got a vertex here at 15, 2, it's got a vertex here which is going to be 25 points something, and 0. Close to 0.6 but slightly less, and it's got a vertex at 40, 0. Well, we've nearly finished drawing everything. The other thing we had to draw was an example of a cost line. Now if you remember, the cost was given by the equation 2.5x plus 15y. So we need to set this at a particular value so we can draw a line that will work. So if we set it at 45, 45 will be divisible by both 15 and 2.5. And so we can see that that would give us two possible answers, 0, 3 and 18. 0. And plotting those 2 points will give us that green line as being our objective line. And so we could label that OL for the objective line. And that's the thing we're trying to minimise. So where do we pick up marks? Well, I'm drawing a line through 0, 5 and 25, 0, that will give us 1 mark. A line through 0, 4 and 30, 0, that gives us a mark. A line through 15, 1 or 18, 0 and 30, 0.4. That will also give us a mark. And then, for having the feasible region correct and labelled, that will give us a mark. And finally, for having an objective line drawn, i.e. with the correct gradient, that will give us a mark. And if the gradient, and if that's been drawn accurately, we get an additional mark. So it's accuracy and method there. Okay, right. Having drawn that diagram, it then says use your diagram to find the number of each type of pack that the builder should buy in order to minimise his costs, and then find the builder's minimum cost. So we got to find the solution to the problem, in other words. So, key thing is then, in this one we're trying to minimise the cost. We have our feasible region, we have our vertices, and the key thing is that these vertices will be the points at which the minimum cost will occur. And to find out which one has the minimum cost, we take this line and we move it parallel and up the screen until it hits the first corner. And the first corner it will hit as we move it up this way will be this point here, and that's at the point 15, 2. So the solution that we're interested in is 15 DIY and 2 trade packs. Making that statement will give you 1 mark. We then have to work out the cost, and so it will be 2.5 times 15 plus 2 times 15. In other words, we've substituted it into this formula for the cost. And if we work that out, that will give us a cost of £67 and 50p. Obtaining the correct value for the cost, making this statement, will give you 1 mark. And that completes the solution. Hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.